Today we're going to begin day one of a two-part lesson on solving proportional relationships. So kind of like we had done with converting unit rates, we're going to break this section down into two sections because we're going to do a focus on what we're looking at today, which would be just basic equations. And then tomorrow our focus will be the word problems. So what we're talking about today is solving proportional relationships, and we're mainly going to focus on how to solve proportions. Tomorrow when we do the word problems, we'll look at more of how to write them and to use the unit rates to write the equations. So today we're basically looking at the basic form of what is a proportion and how do I solve it. Let's get into this lesson. We're going to start as always with vocabulary, and again remember on our top 5 things that we need to have in our notes, vocabulary was one that you guys had said was something that you definitely have to include in your notes, so make sure you include this. The first term we're going to look at today is proportion. A proportion is an equation stating that two ratios or rates are equivalent. Okay, so basically this is saying that there are two fractions and they are equal to one another. In the case of the word problems, when we get to those, it's going to be two rates. Might be you need two cups of flour for 8 dozen cookies, and then how many cups of flour do you need for 12 dozen. So when we get to the word problems, that's where we're going to be talking about the rates. Now for proportions, we have something special called a cross product. The product of the numerator of one ratio and the denominator of the other ratio in a proportion are called a cross product. The cross products of any proportion are equal. So if you're ever looking at two equal ratios, or if you're looking at two fractions and you're trying to determine if they're equal, if their cross products are equal, then you know that those two fractions or ratios are equivalent. So we put a little example of this down here, and I will break down both of these definitions a little bit further in the next 2 slides, but just like the cross products definition says, if I multiply the top number by the bottom number from one ratio to the next, I should get the same answer as the bottom to the top from the next ratio to the next. Alright, so let's break this down a little bit further. Alright, again, a reminder, a proportion is any equation that states that two ratios or rates are equivalent. So we take a look at how this looks in numbers. For example, 6/8 is equal to 3/4. We know that 6/8 is equal to 3/4 because I can reduce 6/8 by 2 in the numerator and the denominator. So that gets me to 3/4. And again, I could go back to that cross products idea, 6/8 and 3/4. If I were to cross multiply, all right, going up this way, 8 times 3 is equal to 24. And going down this way, 6 times 4 is also equal to 24. Okay, so let's keep moving with this. So cross product, again, review. For two ratios, the product of the numerator in one ratio and the denominator in the other is a cross product. If the cross products of the two ratios are equal, then the ratios form a proportion. So again, this is useful in the case of if you get two ratios that you're not sure if they're equal to one another, you could use cross products to figure out if they are. So an example of that would be 4/6. Okay, we know that 4/6 is also equal to 6/9, and it's not always easy to look at those two ratios and say, I can reduce those both by 2 and get to the same thing. I know I could reduce this one by 2 and then this one by 3, and eventually I'll get down to 2/3, but I could also cross multiply to get 36 and 36 and say, hey, these guys are equal because their cross products are equal. Okay, so where is this useful? If you are given a proportion or an equation as such, so we take a look at what we're given right here, use cross products to solve the proportion. Since I am told that this is a proportion, I know that these two ratios are equal, which means that their cross products must be equal. So in the back of my mind, I'm thinking, okay, cross products are equal. So that means that if I can set up an equation stating that the cross products are equal, I can figure out what my variable n is. So cross multiply, okay, numerator to denominator, denominator to numerator, I know that 8 times n is just going to simply be 8n, and 3 times 4 is simply going to be 120. Since these two ratios are a proportion, that means that 8n has to be equal to 120. Now a little review of our one-step equations. Whenever I have a number in front of a letter, we call that number a coefficient, and we know that the operation between that number and that letter is multiplication, so 8 is being multiplied by n, and in order to undo that, we simply have to divide by 8 on each side. Okay, so divide by 8, divide by 8, I now have that 1n is equal to, and I would think a calculator is not necessary on this. We're going to do 120 divided by 8. I know that 8 goes into 12 one time. Subtract, that leaves me 4. Drop down my 0. Alright, 5 times 8 is 40. Subtract, and now I know my answer is n is equal to 15. So in this ratio, in this proportion, I have 3/8 is equal to n out of 40. I set up my cross products. I set them equal to one another. 8n is equal to 120. Divide by 8 on each side. I get that 1n is equal to 15. Alright, so let's give you one to try on your own. I'll wait for about 10 seconds on the video here, and then I'm going to start to go over it, but certainly pause if you need to. Alright, so let's start going over this. I have a over 6 equals to 7 over 9. I'm not quite sure what a could be, but I do know that since these two are a proportion, then the cross products have to be equal to one another. So cross products going up, 6 times 7 is 42, and a times 9 is just going to be 9a. Okay, so I know my equation is going to be 9a equals to 42. Need to divide by 9, divide by 9. I get that a is equal to, and I'm going to get a mixed number here, and that's okay. I'm going to leave it as a mixed number. 9 goes into 42, 4 whole times. 4 times 9 is 36, leaving me 6/9. And I can certainly reduce that fraction by 3 in the numerator and 3 in the denominator. So that gives me that a is equal to 4 2/3. You could get 4.6 repeating, but why not leave it as a mixed number if it's okay to be left as a mixed number? Alright, well, I think we're starting to get this, but what if I bring back those negative numbers? So remember those integers that we worked with earlier, the signed integers earlier in the year? Well, they're coming back with a vengeance, so here's some negatives. So in this proportion, we have negative 2/7 is equal to negative 6 over d. Now, two things are different here. We have the integers, and our variable is now in the denominator. But that doesn't change anything. All I'm looking for is the denominator. Since they are a proportion, the cross products should be equal. Okay? So when I multiply my numerators and my denominators, 7 times negative 6, remember, positive times negative is a negative. So 7 times negative 6 is going to give me negative 42. And negative 2 times d is going to give me negative 2d. So again, I have cross products like I did in the other two problems. So now my equation is going to be negative 2d is equal to negative 42. Same process to undo what's being done to the variable. I'm going to need to divide by negative 2 on each side. Now I know that negative divided by negative is going to be a positive, so that cancels that out. That leaves me 1d, which I don't need to write that 1, is equal to a positive 21, and there's my answer. Alright, let's try this one more time before we get into our problem of the day. Alright, I'll give you guys another 10-second head start. Great. So hopefully you've solved this by now or paused so that you could solve it. But here, there's one thing that's a little different than the last one, and that is that I only gave you one negative number. So we're really bringing back those negatives to review, but we can completely and totally do this. This is nothing new now. So we know that since they're a proportion, cross products should be equal. So 9 times negative 4, that's a positive times a negative, so that's going to be a negative 36. 2 times c, that's just going to be 2c. And I'm going to set up my equation now. I'm going to get 2c equals negative 36. I need to undo what's being done to the variable. So I'm going to divide by 2 on each side. I'm going to get that 1c is equal to, well, a negative divided by a positive is a negative, so that's negative 18. And I am done. Now in all of these we didn't really check our answers. So if I want to check my answers here, it's kind of like we always did with equations last year. We'll just plug in. So 2 over 9 should be equal to negative 4 out of 18. Okay? Negative 18. Well, perfect. Those negatives cancel each other out. And if I were to multiply this by 2 and multiply that by 2, I would go straight to 4 and 18. So I know my answer is right. And we can definitely go back and do that for all of the other ones if we wanted. And I'll let you guys go do that. And then if you have any questions about checking your work, you can definitely bring that up in class tomorrow. So that brings us to our problem of the day. First thing tomorrow, whenever you come in, we'll go over these problems right here. I do want to clarify one of my negatives down here is a little hard to see. This is actually a negative 2/9 is equal to 4 over c. So let me just make that negative bigger. There it is right there. All right, and then negatives up here and here. All right, and then everything else is positive. Good luck. I'll see you tomorrow.